Today, we're looking at a really foundational paper from 2017. It changed the game for AI.
Yeah, it really did. It's called Attention is All.
Okay, what's our mission here? What are we unpacking?
We want to look at what AI models, especially for things like language, were doing before this paper. What were the limitations?
Right, and then understand what this attention thing actually is.
Exactly. And crucially, why it's become like the bedrock for so much of the AI that you interact with today. It's really about understanding the roots of modern AI.
Got it. So before 2017, if you wanted AI to, say, translate French to English, what were people using?
Mostly you'd be looking at things called recurrent neural networks or RNNs.
Yeah.
Sometimes CNNs, convolutional neural networks were adapted to.
RNNs, those work step by step, right? Reading a sentence word by word.
Precisely. And that was a problem, especially with longer sequences, like long sentences or paragraphs.
What was the issue?
The model tries to keep a summary, a hidden state of what it's seen. But imagine reading a really long text. By the time you get to the end, remembering specific details from the very beginning gets fuzzy.
Okay, so connecting ideas or words far apart was hard for them.
Yeah, the paper calls it a fundamental constraint of sequential computation. Information from way back had a hard time influencing decisions later on.
And I guess that step-by-step thing makes them slow to train, too. You can't really do things in parallel.
Exactly. You have to wait for the previous step to finish before starting the next. CNNs could do a bit more in parallel.
Oh.
Yeah, but they had their own issues. To connect distant words, you often needed lots and lots of layers stacked up. So information still had a long path to travel. Learning those long connections was just tough.
So slow sequential RNNs or deep layered CNNs both struggled with long-distance relationships in the data. Then this paper comes along.
And it proposes something radically different. Get rid of the recurrence, get rid of the convolutions, at least in the main processing parts.
Just throw them out. What do they use instead?
Just attention. Rely only on the attention mechanism.
No, wait. Wasn't attention already a thing? Used with RNNs sometimes?
It was, yeah. It was used to help RNNs focus on relevant parts of the input. But the breakthrough here was saying, hey, maybe attention is all you need. You don't need the RNN structure at all.
Okay. So how does just attention solve those problems? The long distance thing and the speed.
Right. So the magic of attention is that it lets the model look at the entire input sequence all at once. Think about translating. Let's use their example, the word bank. Is it a river bank or a financial bank?
Correct.
An RNN sees the, then river, then bank. By the time it gets to bank, the signal from river might be weak.
Right. It might have forgotten.
But with attention, when the model processes bank, it can instantly look back at every other word, river, maybe money, somewhere else, and directly calculate how relevant each word is for understanding bank right now.
Ah, so it can just jump back. Distance doesn't matter.
Pretty much. It directly calculates these relevant scores, these attention scores, between all pairs of words, regardless of how far apart they are. That path for information suddenly very short.
Okay, that handles the long distance problem. What about the speed?
That's the other massive win, because these attention calculations for all the words can happen at the same time. It's highly parallelizable.
Unlike the sequential RNNs.
Exactly. So you can throw modern hardware like GPUs at it and train these models much faster.
And the paper showed it actually worked, not just theory.
Oh yeah. They blew existing results out of the water on machine translation tasks. They mentioned their big model trained in just 3.5 days on 8 GPUs. That was like a fraction of the cost and time for older top models.
So better results, way faster training. You can see why it took off.
Yeah, absolutely. It was a total game changer. It showed a new path forward.
So connecting this back to today, for someone maybe in high school or their parents listening, why does this 2017 paper matter now?
Because this transformer architecture, the one built purely on attention, it's basically the engine inside many of the most powerful AI systems you hear about or use.
Like the big language models, ChatGPT, things like that.
Exactly. That core idea of parallel processing using attention allowed AI models to scale up massively in size and capability in a way that just wasn't feasible before.
So understanding this paper is like understanding the blueprint for a huge chunk of modern AI.
That's a great way to put it. It unlocked a new way for AI to handle sequences, primarily language.
And here's a final thought to leave you with. The paper itself, right at the end, hinted this wasn't just for text. They suggested applying attention to images, audio, video, other kinds of data.
So if this one idea dramatically changed how AI understands language, what else could it change?